So welcome back. We are still moving on with more examples on proving using factor formula where possible. So we are moving to example 2. If A, B, and C are taken to be angles of a triangle, prove that sin A plus sin B plus sin C equals 4 cos A by 2 cos B by 2 cos C by 2. So they are saying that if A, B, C are taken to be angles of a triangle, prove that sin A plus sin B plus sin C equals 4 cos A by 2 cos B by 2 cos C by 2. So what do we know about the sides of a triangle? What comes into your mind? We shall look at that. We are saying sin A plus sin B plus sin C. Want to see that one? Me, I will start from the left hand side. So on the first two items, I'm going to apply factor formula because there is sin plus sin. So this is the same as 2 sin A plus B by 2 cos A minus B by 2 then plus sin C. So we are moving that step there. But we have already said that for the triangle to be AB, for a triangle ABC, when you add the sides of the angles, you equate to one what? They are giving us 180. So we shall say A plus B plus C equals 180. But I can see there is an element of A plus B. I'm also going to create A plus B here alone. A plus B is the same as 180 minus C. There is division by 2. I also divide by 2, divide by 2. What does it become? A plus B by 2 is the same as, when I divide, I'm getting 90 minus C by 2. I can see there is an element of a sign. Also introduce sign on both sides. I say sin A plus B by 2 is the same as sin into 90 minus C by 2. From the compound angle expression, we expand this one. We're going to get sin 90 cos C by 2. We say minus cos 90 sin C by 2. So what does it become? Sin of 90 is automatically 1. 1 times cos C, we are getting as cos C by 2. Cos of 90 is 0. 0 times anything, it goes like that. So that's what we are to having as cos into C by 2. So after coming out with that, we are now free to go on and substitute it there. This becomes sin A plus sin B plus sin C is the same as 2. Where you see sin of A plus B by 2, just put cos C by 2. We say 2 cos C by 2. Then cos into A minus B by 2 plus sin C. We have already substituted in that. Also, the other time when you had sin 2C was the same as what? When you have sin 2C, that is a double angle. It's the same as 2 sin C cos C. Now, what if I have sin C? It's the same as 2 sin C by 2 cos C by 2. Now, we are going to substitute in. Where we see sin C, we are going to bring in 2 sin C by 2 cos C by 2. Then this will go on. This is sin A plus sin B plus sin C is the same as 2 cos C by 2, 2 cos C by 2. Then we have got cos into A minus B by 2 plus, where we see sin C, we are bringing in the expression of the double angle formula, which is 2 sin C by 2 cos C by 2. Again, what is common? What is common in between the plus? I'm seeing 2 cos C by 2, 2 cos C by 2. Bring it out, let's factor out. So we are having 2 cos C by 2 into cos A minus B by 2, then plus cos C by 2. We are coming out to plus sin C by 2, not, we have tried to factorize out 2 cos C by 2, yes, we remain with sin C by 2. We are having sin C by 2 plus sin C by 2. Again, recall that when we had A plus B by 2, we had A plus B by 2 was the same as 90 minus C by 2. Suppose I introduce a cos on both sides. Can we introduce a cos? Cos into A plus B by 2 equals cos into 90 minus C by 2. So when we try to expand using our compound angle stuff, we are getting cos 90 cos C by 2 plus sin 90 sin C by 2. Cos of 90 is the same as what? 0. 0 times anything, we are getting a 0. Sin of 90 is 1. 1 times sin C, we are coming out with sin C by 2, which is equal to cos into A plus B by 2. Now, where I see sin C by 2, I'm just going to bring in cos into A plus B by 2. We are going to express it there. So we go, this becomes sin A plus sin B plus sin C equals 2 cos C by 2 into cos A minus B by 2. We say plus, where there is sin C by 2, I've already proved it, is the same as cos into A plus B by 2. Again now, we are seeing the element of cos plus cos. Recall that cos P plus cos Q was given as what? The factor formula of cos plus cos was the same as 2 cos cos. So which is the same as 2 cos P plus Q by 2, again cos of P minus Q by 2. So we are going to taking A minus B by 2 as P and A plus B by 2 as Q. We are substituting in that. So this becomes 2 cos C by 2 into, we apply, this becomes 2 cos into A minus B out of 2 plus A plus B out of 2, the whole of it by 2 as the formula states. Again cos into A minus B out of 2 minus A plus B out of 2, the whole thing out of 2, close our bracket. So we are proceeding. We need first clean our whiteboard such that we can obtain what was being asked. So we are moving on. We want to see, is that one coming out to that? So we are proceeding. We are still having sin A, or we can even remove what is on top. We've already seen what we want to come out with. So we have got sin A plus sin B plus sin C equals, we are now going to expand inside. This is 2 cos C by 2 into, can we get the LCM up? What is LCM is 2. We are just adding A plus A, 2A. 2A divided by 2 A. A divided by 2, we are remaining with 2 cos A by 2. 2 cos A by 2. We are also come to this, we find the LCM. A minus A goes minus B minus B. We are getting negative 2B. Divided by 2, we are getting negative B by 2. Cos negative B by 2. So this becomes also cos of negative angle, we said is the same as cos of a positive. It implies cos of negative B by 2 is the same as cos B by 2. So we write this is sin A plus sin B plus sin C is the same as 2 cos C by 2 times again 2 cos A by 2 cos, we said the one over negative remains as positive. So when we try to multiply, rearranging 2 times the 2, we are getting a 4 cos A by 2 cos B by 2 cos C by 2. Therefore, sin A plus sin B plus sin C, we are coming out with 4 cos A by 2 cos B by 2 cos C by 2. Hence, proved. That's what we have already done, and has come out with what really they requested us to get.